So equations we're going to look at, solving equations. An equation is an algebraic way of stating a problem. Sometimes you see in newspapers these little problems on the page, you know, Alice has blah blah, is twice as old as her brother who is, and all that, you know, you get these little problems. Every now and then I used to have a go at those things, and a lot of the time you could just write that problem as an algebraic equation and solve the equation. And in an engineering environment, you've got a problem to solve, it can end up being an equation to solve. So part of the skill is being able to form the equation in the first place, and then once you've got the equation, solving it. So there's more to just solving equations, there's also forming the equation in the first place. Let's have a look at an example. Here is a trapezium. Now, there's a relationship between formulae and equations as well. A formula is really just an equation where all the variables are unknown, and you are then left to plug in the numbers and work out an answer. An equation is where you've invariably just got one unknown that you can solve. Sometimes there are two unknowns, in which case you need two equations, and then you need to solve them simultaneously, which we'll be looking at. Sort of stuff I think some of you have done before, if not all of you. Okay. So let's have a look at this trapezium, and first of all, decide how we might find the area of this trapezium. You could divide it up. Yeah, you could divide it up. There is a formula though, but what we do is we could imagine I have a rectangle here where the length of this side and the length of this side, A and B, will be, well no, actually let's not call them A and B because I'm anticipating a formula then that I want to arrive at. So let's call it X and Y. If I could sort of find out what rectangle this came from, or come up with these sides, X and Y, that would sort of fit with this trapezium, then the area would just be X times Y. X would be the height of the trapezium. So that's okay, I could try and find the height of this trapezium. If I knew that distance down there, so I could form a little right angle, triangle, and if I knew this distance and knew that distance, I could use Pythagoras to find it. So, or I might just be given the height of the trapezium. So I need that dimension. But the reason why I've drawn this red triangle on here is to help us to see where the rest of it comes from. Instead of this long side A and this shorter side of the trapezium B, we had two sides that are the same length, which is Y. How could I come up with Y knowing A and B? Equals 2Y, right, so Y equals A plus B over 2, or half of it. How did you come up with that, Wilson? Yeah, that's right. So effectively we're finding the average of A and B. If I add A and B together and divide that by 2, I'll have whatever Y is. So the formula for the area of a trapezium is A plus B over 2 times height. And that's the general formula to find the area of a trapezium. You find the average of the two sides, the two parallel sides, A and B, by adding them together and dividing by 2. And then you multiply that by the height of the trapezium. Instead of writing A plus B all divided by 2, I could write a half of A plus B multiplied by the height. And that is the recognized formula for finding the area of a trapezium. But now we can see how it was arrived at. that formula is an expression or a recipe, if you like, a way of finding the area of a triangle, a trapezium. If I look just at the right-hand side, this expression without the equals sign is telling me what to do to get the area of a trapezium. I add a and b, divide that by 2, or find a half of it, and then multiply that by h. That's what I do. So I could say it in words, or I could write it as an algebraic expression, and that's what has been done there. And I could formulate it, and I've tried to show you how that was arrived at by thinking of your way through the problem, as Russell did, and then you end up with this, okay? So you could have arrived at this formula to find the area of a trapezium. So now let's say we have a problem. We can use this to solve the problem. A trapezium has one side equal to 5.6 meters and the vertical height of 2.1 meters. Find the length of the other side to give an area of 9.8 square meters. So, you know, trying to make this into an engineering scenario, you particularly want one side with 5.6 meters long. You're constrained to a vertical height of 2.1 meters, and you want this area of 9.8 square meters. So what have I got to measure out to get this other side? How long has that got to be? So that's the problem. What are we going to do to try and solve that problem? Draw it. Good idea. Always draw it. And then well, no, what we're going to do is maybe put on the values, right, Brad? So one side equal to 5.6. Well, I don't know whether that's going to be the long side or the short side at the moment. So let's guess and call it the long side. I don't know. I just made those figures up. So it could be the other way around, but that doesn't really matter. We're just putting the values on. We know the height is 2.1, so I know this height is 2.1 meters. And I know that the area is 9.8 square meters. So draw it and put the values on. Good idea. What do we do next? Formula. Area equals a half A plus B times H. Now what? Right. Or put the numbers in. And those are the two choices we have. We can go, and I've sort of divided the board so we can follow both routes and see whether or not we get the same answer. We can either leave the formula as it is, leave it in formula form and then rearrange that formula, and then once we've rearranged it, put the numbers in to get the answer. Or we can put the numbers in at the start, and then we've got an equation to solve because we only have one unknown. So we're going to try two ways. We're going to either rearrange this formula put the numbers in, or we're going to form the equation. So we know that the area is 9.8, and that equals a half times the missing side, well, let's call that 1a, plus the one we know, which is 5.6, and then we're going to times that by the height, which is 2.1. So let's have a go at trying to do that. Divide by h. So a over h equals a plus b, and remember, dividing it half of it is the same as dividing it by 2, so I could write it like that. And if I write it like that, make it easy to see what to do next. Right, multiply both sides by 2, so 2a over h equals a plus b. And finally, what are we after? A. Well, no, leave the a there and move the b over, yeah. So 2a over h equals, minus b equals a. And then we normally write it the other way around because that's traditional. So a equals 2a over h minus b. And then we can bang the numbers in. 2a, 2 times 9.8 over the height, which is 2.1, minus b, which is 5.6, wasn't it? The other way of doing it, solve the equation. What do I do to solve this equation? Similar sort of process. I want to bit by bit undo that right hand side until I'm just left with a. So what am I going to do first? Yeah, move the 2.1 over, so how am I going to do that? Yeah, right, 9.8 divided by 2.1, so effectively now I can actually work it out as I'm going along. So what I might do here, let's just get rid of this, is divide both sides by 2.1. So divide this side by 2.1, that disappears. Divide the other side by 2.1. What's 9.8 divided by 2.1? 4.6 equals a half a plus 5.6. What might you suggest we do now? Right, by true, or not halving the number on the side, James, doubling it, yeah, times both sides by 2, yeah? So I can do that in my head, 8 and 6, 12, so that's 9.2 equals a plus 5.6. What we're going to do finally. Right, so what's the answer? 9.2 minus 5.6, 0.4 is 6, 3.4, 3.6. Not quite the same. Why not? Yeah, we rounded here, didn't we, I presume? When we divided by 2.1, did it come to exactly 4.6? Yeah, it did. Did it? Yeah, did you not notice the recurring decimal, Brad? Above the 6 is a little dot, which means it's 4.66666 recurring. Yeah. So that's a rounding issue. But we do come up with about the same answer. Advantages of solving the equation? Quicker? Did you find that easier? Yeah, maybe because you're actually working it out as you're going along, aren't you? Yeah, exactly, that's right. You sort of work it out as you're going along, yeah. Disadvantages? Could be less accurate because you're rounding as you go along, aren't you? If you're working it out as you go along, you're likely to be rounding as you go along. So it's possibly less accurate. Because? Exactly, James. Yeah, that's its big advantage of the formula. This is a one-off calculation. If I want to do another example where I've got this sort of problem, I'd have to do another equation and solve that. This is a one-off calculation. So those advantages are quicker and it's easier maybe because you're working it out as you go along. Disadvantages, it's possibly less accurate and it's a one-off. So that point James has made there is probably the crucial one. This, the advantage of the formula method is that you end up with a function that describes the situation. And do you remember when we started this year? I could now plot this function. I've got a new formula now, a new function that relates one side, A, the side I'm after, with either the area, the height, or B, depending on what I'm interested in. So if I'm interested in how the one side varies with the other for a fixed height and area, I could plot A against B, putting X and Y on the axes. You remember us talking about this? With A and B, H as constants. Or if I was interested in how A varied with the height, I would leave the area and the other side constant and I could see. So you can plot this function and see how the thing behaves in different situations. So this is a better general solution. But if you've got a one-off problem to solve, form an equation and solve it. Okay? And that's what the rest of today is about, solving equations. Any questions on that before we move on?